All right, so number one said to plot each point, then find the distance and midpoint between the points. So that A point, you're going to be moving forward 2 points, moving left 5 points, because that's your Y, and then up 6 points. Again, it's an approximation. It doesn't have to be exactly where yours is, but I would say for the test purposes, you'll actually give me like those little jumps so that I know that you intended to move up 6 places. It's probably the best thing for me to be able to tell what you were trying to do. And then for B, you moved forward 1 place, you moved left or right, not at all, and then you moved up 2 places. So again, that's an approximation of where B is. I would say as long as B is above the line, just a smidge, it doesn't have to be exact, you would want to make sure that you're in that direction. And then distance, I did 1 minus 2 squared, 0 minus negative 5 squared, and 2 minus 6 squared. You got 1 plus 25 plus 16, 26 plus 16 are 42, and it's all underneath the root, so square root of 42. And you break 42 down into just 2 and 21. Neither of those are going to break down into repeat and be 3 and 7, and all just single numbers, so that's going to stay that way. And then midpoint, add the 2 and 1, divide by 2, that's the 3 halves. Add negative 5 and 0, divide by 2, that's negative 5 halves. Add 6 and 4, divide by 2, that's 8 divided by 2, which is 4. Questions on this one? Okay, second one said, find the standard equation of the sphere whose diameter has endpoints of 2, negative 4, negative 5, and negative 4, 8, and 3. Then identify the center and the radius. You actually had to find the center and the radius this time. If I have the endpoints of the diameter, the midpoint is going to be my center. So I did 2 plus negative 4, which was negative 2, divided by 2, that's negative 1. I did negative 4 plus 8, that's 4, divided by 2, that's 2. I did negative 5 plus 3, that's negative 2, divided by 2, that's negative 1. That gave me my midpoint, which is the center. And then find the distance between the 2 coordinate points, and you should have gotten 2 root 61. That's your diameter. So to get the radius, I would divide it by 2, and 2 root 61 divided by 2 is root 61. That's your radius. So then when you plug it back into your equation, which is x minus h squared, God bless you, plus y minus k squared, plus z minus j squared equals r squared. I get x plus 1 squared plus y minus 2 squared plus z plus 1 squared equals the square of the square root of 61, which is just 61. Everybody good? Yeah? Questions? Any questions on the homework so far? Okay. So these are the solutions to the extra practice. These will also be posted right on the module. I'm just going to put the extra practice worksheet and the answers right on the module underneath 9-6. But number 1, you want to be able to identify that that's a rose because it has the number in between, but R is not squared. It has 5 petals because the odd number that is next to it, you keep that. So it'd be 5 petals. And I know 6 is the length of the petals. So this one was a little bit harder to get the points. When I plug in 0, I got 0. When I plug in pi over 4, I didn't actually work this out. I would have gotten negative 6. The sign at 5 pi over 4 is negative root 2 over 2. And then I would approximate root 2 to be like 1.4. 1.4 divided by 2 is 0.7. And then multiply that out, and I get positive 4.2. And then if I plug in pi over 2, I actually got negative 6. So that's how I found my first petal. I knew this was symmetric to the pi over 2 line, so whatever was happening on the right had to happen to the left. And then that's how you could kind of approximate where the rest of your petals were. And you know that the petal length is 6. That's how you knew that that was the petal. If you plug in pi over 2, that's where I got that negative 6 from, so that's how I knew that it was on the opposite side. Number 2 was limison. A is 4, B is 3, and 4 over 3 would be greater than 1, so this is a dimpled limison. It is symmetric to the pi over 2 line, so I know whatever's happening on the right is going to duplicate onto the left. If I plug in 0, I got 4, pi over 4, I got 6.1, pi over 2, I got 7, 7 pi over 4, I got 1.9, 3 pi over 2, I got 1. So I would say start with those points, and then if you need to plot extra points, for number 1, you may have needed to plot extra points if you didn't understand the graph. Then go from there, but at least start by plugging in those. And then I would duplicate all that stuff, which was on the left hand or the right hand side of my graph. I would flip it over and duplicate it on the left side of my graph. And I knew that it was dimpled on the bottom, so I knew it was kind of a curved edge there on the bottom. Number 3 was r equals -6 sine theta. This is a circle. It was symmetric to the pi over 2 line. The diameter was 6, so I knew from left to right it was 6, or from pole to largest r, it was 6. I plugged in my points, and I actually got at 0, I got 0. At pi over 4, I got -4.2. At pi over 2, I got -6. So everything that was happening was actually happening below my polar axis. But I only plugged in points from the right-hand side, and then I reflected it over onto the left-hand side because, again, it would be duplicated. And then my circle is underneath my polar axis. It went to 6. And from the points, just those points, it was enough for me to make my circle. Number 4, r equals 3 minus 5 cosine theta. This is a limison. It's cosine, so it's symmetric to the polar axis. The a is 3, the b is 5. 3 over 5 is less than 1, so there was actually an inner loop this time. When I plugged in 0, I got -2. When I plugged in pi over 4, I got -0.5. When I plugged in pi over 2, I got 3. When I plugged in 3 pi over 4, I got 6.5. And when I plugged in pi, I got 0.8. No, sorry, 8, not 0.8. So then I plotted those points, which were all above my polar axis, and then I duplicated them underneath my polar axis, and it's kind of hard to see up there because it's light. But I knew it was an inner loop, so I just make sure that I connected it, which made sense with my points. Made sure I connected the outer ring and then looped it on the inside. Number 5 was 4 equals cosine 2 theta. This is again a rose. There's 4 petals this time because the number next to the theta is even. I double it for the number of petals. The length of the petals was 4, and it was symmetric to the polar axis. So I plotted the point. I actually plugged in 0 and got 4. So right away I knew if I plugged in 0, I get 4 cosine 0, and the cosine at 0 is 1, so I got 4. So just from the first point, I knew I got my radius was 4, and that's where I found the first petal. And then I knew it's 4 petals, and I know it's symmetric to the polar axis, so whatever happens here would also reflect over here because that's the rose with 4 petals. And then it's actually symmetric to the polar axis and the pole and the theta equals pi over 2 line. So I knew that it was symmetric in all the ways, this way, that way, and this way. And then the 6th one I added on because yours didn't have a lemniscate. So my advice is if you started it already, add on 6, make it r squared. So r squared equals 4 cosine 2 theta. Remember, if it's r squared, it's a lemniscate, which means it's symmetric always to the pole, but because it's also cosine this time, it's symmetric to the polar axis and to the pole. The a squared is what's in front of the cosine, so the a squared was 4, which makes a 2. That's as far out as it's going to go. And then I started plugging in some points. So when I plugged in 0, I got 2. Right there, I knew that there was this loop. And then it was symmetric to the polar axis and to the pole. So if I were to flip this over the y equals x line, or down and over, I would get the other side to be where it is. Actually, this one is, yeah, it is. Because if you plug in a negative r and a negative theta, it's going to go back to normal. The negative r is going to go back to normal, and then the negative r and the negative theta is going to go back to normal. Questions? Okay.